In this video, I'm going to show you how I model stairs in Rhino. I'm going to show you some things in Rhino 7 first, just so you know that there's some alternatives to actually doing everything manually, like I'm going to do for most of this video. Also, I'm going to just more or less do the modeling. I'm not going to get into stair geometry, stair code too much. So I'll just, by the time you've watched this, you'll have a few different ways to model stairs, but as far as things like building code, it's more, I guess, specific to your locality. That won't really be covered in this video. The last thing I'll mention, I'm just doing the stairs, the risers, the treads, the stringers, a little bit of the supports. I won't be doing railings in this video, but I might pick one style of stairs and do a video on me modeling the railings for those stairs. Okay, so as mentioned, here I am in Rhino 7, so I can show you visual arc really quickly. So it has a few options for, well, one main option for stairs. Basically just draw stairs like this. I can put a crank in the stair if I wanted. I'll draw one more. Let's put the height to 15 feet. Just so I can have it going in a complete 180. I'll have to draw that again. So it does a good job of drawing stairs. If the stairs aren't quite right, you can always, I think there's a VA explode. I think I just use maybe the normal explode command. I can delete that surface, and if I really wanted, I could probably do whatever I felt I had to do to fix the surface. So yeah, even if your geometry, whatever the supporting structure is, isn't quite right, at least you have something really good to start off with. So that's one alternative to manually modeling stairs. So next thing I will show you is a couple of grasshopper scripts I made. These I don't share them because they're kind of clunky, they're kind of messy. Since I made them myself, I know how they work, so they work for me, but it would be hard to justify sharing them with another person. So anyways, I'll see if they come up here. I have one for saw and lumber stairs and one for concrete stairs. But yeah, I don't want to spend too much time on this because it's not really the point of the video. The other reason I don't share these is because if you use the wrong definition, the wrong grasshopper definition in a file with different units, it will actually crash your Rhino. So for now, I'm not really sharing these. But yeah, so I have everything I need to create my stairs quite quickly. If I'm not mistaken, I think I have provisions in here that actually accommodate for material finishes. So if the treads have a finish on them, or my upper floor and lower floor have different finished floor thicknesses, I think this accounts for it. But truth be told, I don't really use these too often. So I'll go here, I'll go bake, click OK. So now I just have a straight run of stairs, right? So what if I wanted to put a landing or something in? What I do now is I just take or draw a plane where I want my landing to be. Let's see if I can do Boolean split. That should have hopefully a closed solid poly surface. So yeah, with that, I can just take the stairs. This is basically the same way I do if I manually had drawn those stairs. That's exactly the same way I would insert my landing, obviously, but just a little bit more carefully. Okay, so I can do that, and then I can take that. I wish that remembered my gumball location. Put that to 180, put that there. And yeah, so from there you kind of get the point. I just draw my landing in. And it's not, I could make a grasshopper definition with a landing, but I can do that so quickly. I'm fumbling around a little bit because I'm used to Rhino 8 and I got my microphone rate basically sat on my keyboard, so normally I could do that a little bit faster. Once you're used to doing stuff like that, you can do it really quickly to the point where even if I spent the time making the grasshopper script, I'd still be faster at doing what I just did if I'm drawing these stairs quite frequently. If I'm drawing hundreds of these at a time, or sorry, not at a time, but let's say I draw just tons and tons of stairs every week, in that case, maybe I would create a grasshopper script. So I'm just I was gonna show you one more. I have one for concrete stairs too, but I don't know, I kind of want to move on. But anyways, back to what I'm saying is that you might not want to create a grasshopper script if you're just modeling something that's really a one-off or even just slightly different than something slightly outside the constraints of the definition. So hence why I'm going to move into Rhino 8 and show you my methods of manually modeling stairs in Rhino. Okay, so I'm jumping into Rhino 8. I've been using Rhino 8 a lot more lately, and it's just starting to feel more... actually, going back to Rhino 7 now feels a little bit awkward. Just the way you select things, it's different in Rhino 8, but better, but it takes getting used to. And likewise, if you go back to Rhino 7, you're going to lose some of those luxuries. So what you're staring at right now is my previous attempt at making a video. I modeled all these stairs with no sound and was just doing a voiceover, but then I realized that if I just model these in real time, it's probably way more valuable to viewers than just explaining what I did afterwards with the video fast forwarded. So I'm just gonna model the stairs, make my mistakes, and yeah, you'll be able to see actually how I do this stuff in real time. It's nothing groundbreaking, but it'll just give you some ideas as methods you can use to model your own stairs. So I'll set the display mode. I already have some layers set up, but nothing, nothing special. I have some dimensions ready, and I have dimension style showing feet and inches. I'm going to put my my floor to floor height as 10 feet in this example. So anyways, I guess we're ready to get going. So I'm going to draw a vertical line. So that's 10 feet, which is 120 inches. So I don't want to get too much into the geometry, but this is more or less how I'd figure out my tread heights. So yeah, if I divide that 120 by 7, 7's my target tread height, I get 17. That gives me, that would roughly equal 7 1/16 of an inch tread height. Divide that by 17. So just to let you know, I'm showing you the first method of creating stairs. Okay, so I have my tread height. I got to establish my, I guess my runs, my run distance, as well as things like nosing. And as you can see, I have that left over from my previous work. So I'm just going to draw a box. Just give it an arbitrary depth. Drew that up instead of down, so I'll move it down 0.75. Okay, so I have a tread. I'm going to change the layer to stair treads. Maybe I'll make that, let's make that maybe gold. We'll go with that. Okay, so I have a tread. I want a 1-inch nosing, so what I'm going to do is just copy this up. Now this isn't the most glamorous way to draw stairs, but it works. And all you have to do is find a way that you like that's reasonably quick, you can remember, and yeah, and that's about it. There are faster ways. So that dy, this is the, oops, sorry. I have my coordinates mixed up because I'm so far away from my origin. But anyways, I'm going to do that. I'm going to do there we go. So that's my 1-inch nosing, just so you can see what we're doing here. So yeah, if I have 17 risers, I should have 16 runs, right? Unless you count the the very top of the stairs, which would be your upper finished floor height as the extra run. So I could do the math there and figure out, like, for example, I could have drawn a drawn a line, something like that, where that distance would be my the sum of all my runs. But it's easy enough just to copy these. Just be careful when you're copying them, because if you get your copy point slightly off, it's going to be a bit of a mess to clean up later. But yeah, so now I have 2 treads. Once I get a few copied, just again, same thing, carefully, just keep copying them, and eventually I'll just get to that point where measure my distance. My DZ indicates I need one more tread. So yeah, it's kind of a sloppy way of drawing stairs, but it's easy to remember. So if you're not drawing stairs all the time, that's just one way to do it. I did make a little mistake. I drew, or no, I didn't. I thought I had this down here, but we're okay. Okay, so what I'm doing now is I have my let's go to this layer. So with my treads drawn, I can now draw my stringers. So I'm going to do that, that. Put that there. I want to move this back the same as my nosing. 1. So I can just trace this all the way up, or copy it. So again, if this isn't something you're drawing all the time, it takes a few extra seconds to do this, but it's literally just that, a few extra seconds, right? So I got that, I'm going to join that, I'm going to copy this again. That's up there, it's going to shoot past, so what I can do now is just go trim. So I need the throat, or I guess in this case I'm assuming these are frame stairs, so I'll just go like that. I'll go offset, distance 11.25, that's a 2 by 12, right? Or a whatever by 12. I got that. So for myself, I rarely encounter wooden stairs. Usually construction workers just figure that out on site. In theory, maybe I'd prevent some mistakes, but the stairs I do draw all the time are concrete stairs, so that's something I made a grasshopper script for. So I'm going to extrude that 1.5. Copy it across. I don't think that's actually in the middle. Let's check it. Okay, so that's our first set drawn. I'm actually going to use these. Again, so let's throw those over there. Okay, so the next method is actually the first method I wanted to show you because it's kind of a maybe easier for a lot of people. Okay, so same deal as before. Let's go to this layer. Bit of a color change. So this time I'm actually going to draw concrete stairs. This is probably how I do them manually if I didn't have that grasshopper script. So I'm going to set my C-plane to this object. Better way to do it is actually like that. Now I got my, that's just the set C-plane by 3 points, right? So for me it's the most reliable because now my X axis is facing the right way, the Y axis is facing what for me is the correct way. Okay, so let's draw some lines. I got my line. And use a 1-inch nosing again. So I wanted 11-inch treads. This is a very common arrangement for concrete stairs. It's actually the most common. You always aim for 7-inch treads and 11-inch runs. And you only don't do that, at least where I am, if there's something in your way or you need extra clearance on a landing or something, headroom or whatever. But if you can do the stairs like this, and I'll just give you a quick visual of what we're actually drawing here. So yeah, I have my 1-inch run, my 11-inch tread. So I have that. Now what I can do is just join these lines. Again, not the most glamorous way. We're just gonna, copy it. But not from there. I want to copy it from right here. And like before, just double check before you copy everything. You know you're good, right? Okay, let's join those two together. Those three. Similar to before, so this might actually be a better way to draw stairs outright, but now I'm gonna draw the throat again, offset it. Fill it that, because I need a line here. Delete that. Let's see if we can join. Join that together. There. So we have our concrete stairs now, right? So when you're tracing your stairs on the side of something like this, it doesn't have to be all one object. You can actually, for example, you can draw yourself a rectangle. Then trace your stringer out. So the advantage of doing this, I'm going to show you why I do that in just a second, because I actually forgot to tell you something very important. But now you can extrude multiple curves, and you have like these separate treads. So for example, if you wanted to change the layer of them, you can do that. But yeah, so the real reason to do stairs this way and not this way or this way is because if you turn your tread into a block, then you can edit that tread, edit all the treads by just editing a single one. So what I should have showed you when we did this flight is that turn this into a block before you copy it up. Okay, so I just took a quick coffee break. I could talk about this a lot, but it's better just to show you exactly what I meant. So I deleted all the treads. I'm going to turn this into a block. Base point doesn't really matter, kind of, sort of. Just named it that. I think I have another one of these in the file already. So okay, we have a block. Let's just turn it to the right layer as well. Inside the block, the poly surface is my stair tread layer, but outside I had it on that other layer. Speaking of which, we'll just set it to default. Okay, so since I already have these treads drawn, I might have a little advantage here. Let's see if we take that, put that there. With 16 runs, 17 risers. So I just needed a visual cue there. So let's take this array curve, items, let's put that as 16. So you can see it's not going quite where we want them, but it might be an easy fix. If I really wanted, I could just move these all at once. Get those out of the selection set. I think if I just go like this, boom. And that did not quite fix our problem. So obviously you can just copy them up like I did before. That's kind of, you know, I kind of want to figure this out. So let's try that again. Let's do array curve. Select this. Let's try the base point. Let's do that. Let's do that. Okay, there's only 17 runs, but this top one counts as an extra run. So what I did there is I just had one less item. And that's what I said earlier. I'm just going to record, make my mistakes, because at least if I make mistakes, you might learn from them anyway, so it's not really too detrimental. Plus, it makes it easier to keep up if you're new to Rhino or whatever. I'm sure it'll be way faster than me after you've used it a little bit. So anyways, enough talking. Let's actually demonstrate the advantage here I've been going off about. So I'm going to divide this guy by, let's do 3. So extrude curve direction, extrude surface, both sides, let's do by 1/8. I don't know what I got going on here. If you're wondering how I set my camera, I pick an object or objects around where I'm working, and then I just do, I got a F1 map to zoom extents. Anyways, let's just delete that. I just drew that line in the wrong place. Way around that is use the line vertical option. Kind of the side quests in this video are taking more time than the actual reason I made the video, or I'm making the video. So I got that there. Let's just copy that there. Boolean difference that with these. Do fillet edges. Oops. Fillet edge. I don't know, that should be plural. Next radius. See if it actually does it without breaking anything. I think it did. Okay, let's hit OK. And as you can see, if you had to do that to every tread, obviously you'd never want to do that to every single tread. So we now have our second type of stair. Anyways, I'm going to fortunately have to undo that, because to show you the next method of drawing stairs, actually I'll break the video just in case I make a huge mistake and want to start over, but the next thing I'm going to show you is winder stairs. So I'll just simplify the stairs a little bit just to make the video flow better. Okay, a quick sip of coffee and we're back at her. Now I did say we're going to do winder stairs next, but I'm getting ahead of myself. What I want to do first is just make a landing, and I already did this in this video, but I'll show you how I'd actually do it on a real job. And I would go up 5 feet. That's about halfway. Because remember, my floor-to-floor height in this case is 10 feet. Ends up there. So I could either go up or down, right? So I'm going to take this, go up. One thing I'm going to do is explode those blocks I just created. So yeah, basically I did that for nothing. Kind of, sort of. Not really. But anyways, that's not important. So we have that. Let's split. Boolean split. I only started using Boolean split recently. I didn't realize it existed, so I was always using the split command. Well, sometimes Boolean difference, but sometimes using the split is more reliable. But yeah, I didn't know there was a Boolean split. I didn't bother to look. So unfortunately, that meant I was always splitting objects and then capping them. Okay, so I mentioned I don't want to get too far into stair geometry, but the more distance you put right here, if you have stairs that actually make a U, the better the handrails are going to tie in together. I think the handrails, the stairs are arguably the easier part. The handrails can be really, really challenging. So yeah, you could make a grasshopper script for this, but I find that for me, it would just take, I don't think the number of days of my remaining working life would justify spending the time on script. And then I find once you get into not so much landings, but the winder stairs and more complicated stairs, just any small difference can render the grasshopper script in that instance kind of not worthwhile. So you have to do like a cost-benefit analysis, the cost being your time, of course. If you enjoy making the scripts, absolutely build them. It's totally worth it if you enjoy it. But for me, keep in mind that I'm talking and modeling, which makes me a little bit slower, and I have my microphone on my keyboard. So normally if I was doing this, I'd be a little bit faster. Anyways, let's Boolean union that tread. Let's Boolean difference that guy. Now if I wanted to put the support on, what I would do is, let's grab that, Alt left click. Let's do -8. Okay, so I got that there. Next I'm going to do extrude curve. That's actually going the way I want it, so that's good. Extrude curve. That goes there. So we're just doing a quick support. So I'm going to do split face. Split face. Let's try that one more time. There we go. Enter. Split face. The command wasn't working, but I'm using the wrong command anyways. So let's do instead intersect. That's what I really wanted to do. And once I spell it correctly, you'll see how good it works. I do Control Shift left click, grab that face, this and this, and do enter. There. Now let's do split face. Split face, select curves. See, that split the face for us. Okay, so now we're in business. So I can do. Could have just extruded this curve. I should have just done that. I'll do a copy, extrude. Having some graphical glitches going on there, so that's not the best sign. I think my computer's getting a bit dated, so and this one I only actually have to extrude at a 1 inch, but at this one as well, 1 inch. Merge all coplanar faces. And then match. There. So that took a bit more time than normal, but whatever. But yeah, so if I was actually modeling this, just working, not talking, I could do that a little bit faster. If you draw enough stairs, it'll get even faster. And then if you're drawing these all the time and your landings are very similar, you could probably get away with or not get away with, but you'd probably benefit from investing time in a grasshopper script. But in this case, for me, I'm going to be way faster throughout the remainder of my career. I'm not a young guy, manually modeling stuff like that. Okay, so next we're finally going to get to those winder stairs. Okay, so let's finally move on to the winder stairs I was talking about a little bit earlier. Okay, so for winder stairs, I just kind of wing it. I rarely ever encounter winder stairs, and for that reason, I guess I never really developed or perfected my workflow when it comes to drawing them. But as long as all this stuff, if you don't draw it very often, you just have to have a way to do it that isn't horrendously slow or sloppy or gets you the wrong result, right? So for me, I don't worry so much about speed or, like doing it the fastest possible way I can. I find that whether it's AutoCAD, Rhino, or even other programs, sometimes finding the fastest absolute way to do something, you'll just forget it anyways, right? So just having a way to do it is kind of the goal here. So yeah, if you do know of a better way, feel absolutely free to show in the comments. Even link your own video. I will take no exception to that. So here I'm just kind of pondering what I'm going to do with these. When you make the winders, you actually eliminate treads. Normally, like, you could draw your winders out on the ground plane, but since I already have the stairs, it'll be a little bit quicker just to work with what we have anyways. And the thing is, at least for me, when I was doing winder stairs, I had to figure out the geometry kind of like on the fly anyways, right? So it wasn't like I just got to sit down and just start drawing them. I knew exactly what the dimensions were going to be. I had to play around with them. I had to get the landing at a certain height. I had to get the treads a certain shape. Yeah, one thing I don't really cover here is like building code and stuff. Your treads, there are rules for the treads, and it varies depending on the code, the year, your region, your country, all that, right? So I'm not getting into that, but I'm just going to try to end up here with reasonable geometry, let's say. Okay, so enough talking. Let's finally draw these things. Okay, so I have my split right there. To make this easier on myself, what I'm going to do is incorporate one run on each side into the winder area. I didn't mean to do that. Vertical base point. There we go. Just gonna hide that for now. I don't care about it for the time being. Boolean union them. Okay, so if I put a 45 degree here, I'm going to have 1, 2. And that's going to look the cleanest. That'll make it the easiest for this video. If I do that, I don't actually need to move those treads. So just let me ponder this for a second. I want to do something a little bit more challenging. I don't just want to do 45 degrees because that's kind of almost a cop-out. But yeah, don't let me forget to tell you that there are rules for the shapes of these winders. You can't just make it any shape you want necessarily. This looks like it would be the code. I'd have to actually review that a little bit. Usually the main part about code is this part right here. You're sometimes not allowed a sharp point. But to be really good at making stairs, you're going to have to read a book or two on the subject. And then certain clients, for example, I was working on kind of like a penthouse, and the stairs were going to be really, really steep. I could go into stair ratios, but it would be considered a less than ideal stair ratio, but the client didn't really mind. Like, some people like that. I know if you go to Europe and stuff, some of the older houses have really steep staircases, and for some people it feels more like home compared to having a stair that's comfortable for, I guess, like any random person that stumbles upon them. But yeah, this is taking a bit longer than I had hoped, so I'm gonna try to step on the gas here and get moving. So I want to maintain my 1-inch nosings. So I'm going to offset all these by that 1 inch. Just going to measure this, see if my nosing's still there, which it is. Okay, from there I can now trace out these. I'll have to do some extensions. So extend. I could trim that, I don't really need to. Let's reset my camera. Yeah, a lot of people, they don't like Rhino because they find like the camera, similar problem in SketchUp, gets out of whack. But if you just click something near where you're working and use that zoom selected, that will fix your camera right up. I think that works for me 99.999% of the time. Anyways, let's do our polylines. So you're watching the video and you're getting impatient. The moment that you start seeing me extrude these would probably be when I'm ready to move on to the next stage. So we got one more. So this actually took me a little bit of time, especially compared to the last video. I was able to make these quicker before. Let's see, I still got one more to do, don't I? But I'm drawing them slightly differently. I don't know, I just get bored sometimes, so I want to kind of try new things. But yeah, so it's taken a bit longer than I had originally anticipated. But I think the method I'm using is better than what I did in my last video attempt. Okay, so extrude that. Move it vertical. And I use one tread as my reference. Okay, so here's the thing that's going on. I got to decide where my stairs are going to start and finish. Because each winder, so the good thing about winder stairs is they actually give your stairs like less of a footprint in the building. They'll take up less floor space because instead of just having a landing, now your landing is creating some rise, and it goes without saying, obviously. But does mean there'll be a little bit of tweaking. Okay, so I got that. So it's taken a while, but I'm being a little bit careful because I don't want to recreate this video. Because I already made the other video, so yeah. So thanks for putting up with me being a little bit slower than anticipated. So I guess I forgot to draw that one too. Okay, so let's do one more. This. We don't actually need this. That's probably getting in the way of in the way for you guys too, isn't it? Let's extrude curve 0.75. And I forgot my edge. So solution here is like what I do is I just change colors if everything starts blending together. you run out of colors, it's probably time for a little bit of a cleanup. And I did it again. Okay, let's delete that. So instead of moving stuff like that, it would have been smart just to keep this handy as like a reference. But I'm so far in right now that I'm just not gonna bother. Okay, so I got that. So this I have to move it vertically, and I'm gonna go 2 risers. Could also use set point Z. So my tread depth is 11. I've been using that the whole video so far. So that Boolean split just to get the So I'm just checking my Z distances, which you can see right here. So now I'm making a good business case for a grasshopper script, but to be honest, the problem with automating winder stairs is that if things deviate outside what the script can do, you'll have to manually model them anyways. But I think there is things available. When I showed you Visual Arc earlier, you could use Visual Arc to get your treads. And if you don't like the mass modeling beneath the stairs, you can just explode and explode the stairs and just keep the treads, right? But yeah, so normally, to be honest, that's the first time I did them exactly like that. One thing I might do in the future is just draw the treads on the ground and then move them up or something. I don't know, but that worked quick enough, and yeah, it's not blazingly fast, but it gets the job done. There's not a lot of memory involved in how I actually model these. And I could do the supports, but I kind of want to move on further into the video. If you want a video of me doing that, I could whip one up really quickly, but there's nothing really to it. It would just be a bunch of extrusions. Should mention, I'll just take a quick second to mention that when you frame underneath your winder stairs, I think that's a big case for doing them in Rhino. If you figure out what's underneath here, if you can just fill up underneath the winders with framing, that's the easiest to build, but you end up with a lot of void space. Whereas if you make the framing more complicated, you can take advantage of the space underneath for storage, or if you have a second flight of winder stairs below these ones, you might need the headroom anyways, right? So there's all those considerations that I'm not really covering in this video. This would probably pose a bit of a headroom challenge. But yeah, there's a little bit more to it, but at least I showed you one way to model your winder stairs. Maybe I'll pause the video, finish the supports, and then move on to the spiral stairs. I'm going to split the spiral stairs into two different ways. I find if you have a narrow inner radius, that kind of changes the whole deal quite a bit. So I'll do the narrow, or not narrow, but small inner radius first, and then after that I'll do a large inner radius. You'll see what I mean if you don't, if I didn't explain that too well. Let's do a circle. Let's make it 12. Let's offset that circle 3'9". The 3'9" is just a number. Just a number I have in my head from seeing so many stairs. Where I am, 3'9" is a really, really common number for stair widths. It's not the only number I see, but it's probably one of the more common ones. Okay, so when you draw these, you'll probably want to keep some reference geometry, and for that reason, let's actually make a layer that is a distinctive color that we might actually lock later on. Let's take our vertical line. That should be 10 feet, right? Or 120 inches. So what we want to do is draw a helix and use the vertical option. So with this, it might help to do some math first, but I think in this case we're just going to wing it. We don't want 1200 turns, I promise you that. I'm going to do 1.5 turns, and we'll just see what we get. By looking at this, I can tell that, remember that's 10 feet, that line, we won't have enough headroom. So if your turns are more than one, that is a sign, especially on a low floor-to-floor height, that is a sign that you could run into clearance issues. That is probably going to be okay. So that's the first problem, is going to be your ensuring you have enough clearance under your stairs. Obviously that's 10 feet. And the second will be figuring out a good tread width. And you'll see what I mean just in about 1 second here. We're going to divide this by 17 was our number. Divide. Okay, so if we divide that by 17, we should have our same riser height, right? And we do, so I guess the right number. But the issue is that these risers are way too, just look at our actual distance. The distance is just way too much. I can tell that much, right? So what we'll do is just undo that, delete this, and we'll draw another helix. So the way to prevent that actually is just to, okay, so 17 risers, 16 runs. So we know roughly rotate, let's actually copy it. So I don't know why that went so wrong. Maybe it is because I have my microphone right in front of me on the keyboard, so I can't really see what I'm pushing or typing. But yeah, so we have a 4 inches. Actually, I'm going to make this easy on myself. I'm going to take this, put this here, and now I can just do Alt. To be honest, I like the Alt click. Let's do 10 degrees. I like using the gumball when I can instead of using the commands. It took me a while to get used to it, so I did 10 degrees. Let's rotate it another 2.5 and check that. So similar to before, there's going to be code issues that dictate likely how tight this right here can be. So I realized that my what I'm recording isn't really showing the cursor, is it? But that distance there is going to have a minimum per code, but I don't want to talk too much about code. That'll be for you to figure out, right? So anyways, let's make that, let's rotate that another 2.5. So dim angle is 15 degrees. So 15 degrees times, what would that be? That should be 16 runs, right? But we need to divide it by 70. Anyway, I'm going to figure that out in just a second. So let's do 15 times 16 is 240. So let's do the helix. So I said 240. I'm sorry for this, but I actually have to. 240 divided by 360 is 66.6. So turns. Oops. I gotta start over. What a mess. Okay, vertical. Turns 0.6667. Okay. Divided by 17. Copy vertical. So it won't hurt to show you that one more time because I've accidentally not added that extra 1 number to this. So 15 times 17 equals 255 divided by 360. 0.7083. Let's do divide. Okay, so finally we got something we can kind of work with here. So I'm going to take this. You'll want to keep your reference geometry, and I'll let you know why in a little bit here. Let's trim, use those. So the way to make a good video is to record one, then figure out all your mistakes, and then re-record it. But unfortunately I don't have time, so I'm probably going to upload this as it is. So normally I do stuff like that, but I just quicker, I guess, if I'm not recording, if I'm not talking. Let's do 0.75. Let's do 1. Want the tread to have a little bit of meat to it. Okay, so for before we forget our numbers, let's draw another helix. Vertical. Let's divide that helix. Now you'll want to keep both the inner and outer helixes, and for that matter, maybe the points too. I don't think I need this anymore. I don't think I ever needed that, did I? So let's change the layer of a lot of this stuff. Let's change it to our reference geometry. Curve, we don't really need that. Let's change this to, where do we want that? Whatever, right there. I'll name it 2 because I think I might have another block with that name in this drawing already from that last attempt. Okay, so we got that there. Let's just double check our, I should have checked that before, but we're good there. Let's do array curve. Select objects to array. I don't think it matters which one we do, we just have to select the right orientation. Road-like does the same thing. Just fun to see what it does if you use the different options, right? Okay, so you do see that we have the extra tread up there, but obviously that's no real trouble to get rid of, right? Okay, I think we're good there. So normally if you have a tight inner radius, usually they have a metal pole. This one would actually be pretty big, supporting the inside. And that metal pole is also the tread support sometimes as well. In this case, I'm not quite sure if they'd actually do that or not. But yeah, I could go further here and do something cool with the outer support. But this video is kind of taking a bit longer than I intended, so maybe I'll save that for another video if I actually spruce these up and make them look nice and pretty. But yeah, I think I've picked a strange medium here where if you really want to make constructible spiral stairs, you either have to make the inner radius narrow enough where you can just use like a standard rolled section as the middle, or as the the middle support, or have something going on the outside or whatever. But yeah, this would be a kind of a tough radius to deal with. Once you get into larger inner radiuses, then you lose that issue of not having enough support distance right here, right? So if this tread was sticking out further, you'd be able to put more, attach more meat to whatever was supporting it, both on the inside and the outside. So that's kind of why I'm going to do a video on the larger radius spiral stairs. I also use a method more similar to when I drew that plane. And then, you know, like trace the stair shape on the, I know those are great looking stairs, but whatever. And then trace the shape of the stair on that plane. I do something similar with larger radius stairs, at least with concrete stairs, to that, but I traced it on a extrusion instead. So anyways, enough about that. I do want to make a full video on kind of like dressing these stairs up with railings and supports and everything. I might do that either with these ones or these ones, depending on time, demand, and whatever. But okay, time to move on. Okay, so large radius spiral stairs. Let's draw a circle. Let's make it 18 feet. Let's make these really, relatively big. Do the offset again. 45, which is 3'9". We'll go with that. Do a line. Center. I'm using a snap override there. I have center turned off because it's just too strong of an object snap relative to the other snaps. So if you do that, you won't be able to use the center snap unless you type center. Then it overrides my setting just for the time being. You can do that with anything really. You can do that with near. That's another one I have turned off, but I use once in a while, right? So that comes in useful. Very similar to AutoCAD, which I appreciate too. It makes it easier to jump between the two programs somewhat. Okay, so we got that. Similar to before, we got to figure out, let's move that here. Do Alt. Let's just start with 5 degrees. It's way too much. Let's do 3. Foot 1. So the bigger the radius gets, the more square the tread actually is, right? So that's kind of a advantage you have to work with. What was that, 3? Let's see what happens when we do. Let's do 2.75. I think that's going to be the winning number. It's 10. That's 12. One important thing to note here is that I am going to offset this. So what I'm going to do here and here is change the layer of these guys. I'm going to do offset 1, and that will be my nosing. There we go. It's hard to see, but that gumball is set to the C-plane, not the world, so I just got to stretch it out a little bit, arbitrary distance. Okay, so I got that, and I copy these in place. Again, I'm going to need reference geometry. If you're doing this in real life or something, you're going to want to save these two circles rather than try to memorize the radiuses you had drawn them at. So I just overlap them. I'm just going to select this one. I'm going to select this one. Just going to hide them just so we still have them. Now I'm going to do FR0. See if that works. Wasn't quite what I hoped for. Okay, got that. Now I can just get out of that command. Okay, I want to keep that just for reference, but I might not need it. But what I'm going to do is select this, trim. Let's get rid of actually, I don't quite want to get rid of this yet. And I can just draw a line from here to here anyways. So let's do a planar surface. Select that, 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 and that. Could have just extruded surface, but that's alright. Actually, I don't need to do that. I'm kind of getting ahead of myself there. Okay. Anyways, let's bring these guys back. Let's change the layer to those, that reference geometry layer. I think a darker color might make the video make it a little bit easier on the viewers, I guess. Yeah, I'm not, it's not really my strong suit, picking, I guess, suitable colors. That's something I gotta improve upon, I guess. Okay, so anyways, there's this. Rather that just be centered. Okay, so I'm going to do line, vertical option, center. Just to do things a bit different, I'm going to make this 15 feet. It should draw that line vertically since I used the vertical option, but let's just make sure. Should be 2 zeros and a 15 foot. Okay, so we got that. Let's make 7-inch high risers again. So 15 feet times 12 inches per foot. Let's divide that by 7. Gives me 25.7. So let's say 26 risers, meaning I'm going to be a little bit under that 7 inches, but that's okay. So 15 times 12 divided by, what was it, 26? 6.92. So that's about 6 and 11, or 6 and 15/16 inches, roughly. Let's divide that guy. Did I say 26? I can always check it. There we go. Let's change that to our reference geometry. We do want to keep this. And it's good to, if you have a sketch pad or notepad or whatever, it's good to make notes or even just type something like that, right? Got coffee. Well, I'm reaching the end of it, so my memory's a lot better if I'm caffeinated. Once that runs out, it's pretty sad, but I think we'll be okay for now. Okay, so anyways, let's try to keep going here. Okay, so I'm gonna do dim angle. I think I did 2.75, right? Is that what? I think I saw 2.75 flash up briefly before whatever happened. So we're just gonna go with that. So 2.75, 26. Times 26, that equals 71.5. That's so divide that by 360. Remember, that's 1 turns 360. That's 0.1986. Actually, let's just Control C that. Let's do a helix. Vertical option. Kind of jumped the gun there, didn't I? Let's do that. Same thing, helix, vertical option. So that looks kind of sort of about right, but we're going to see in just a second here anyways. I'm going to copy this to here. Not necessary, but it might make it easier to see what we're doing. Let's copy those curves up. So I should have offset that curve too. But it should work out. going to do extend dynamic just so I know that my that these are intersecting, just in case they were off slightly. It could throw me off a bit. So I'm going to draw a line from here to here. The shape, the profile of these stairs is going to be similar to those concrete stairs I drew earlier. Okay, so we have that there. That there. So we're going to see how that ends up. We're going to do a join. Same over here. My grid snap got turned on, so that might cause some issues. I'm actually going to redraw that just in case. Showing those together. Think that okay, so we're going to do an array curve. Objects to array. Let's do items. Let's do 26. Items 27. Okay, so I shouldn't have deleted that little piece there, so let's undo that, undo that, undo that. Let's do... Actually, let's... change the layer, it'll make it easier to join them after. The way I'm doing this, I might have an extra riser right there, but that's pretty easy to check. dz equals, and that's plus 6 and 15/16. Now if I go that way, it's negative, so you delete that, check that again. We pretty much know the answer is 0. It's just that you want to make sure you get this all right before you really get into starting to work on the support for this, because that's when you actually have to start doing a lot of modeling, I guess. One thing too is I might make a landing, since this is quite a long run. I don't think it might not be to code. Let's do 7.5 feet. Let's see where that ends up. Right in the middle. That's pretty cool. Let's just mark that. I want to look at something too. Just looked like some of the line work was off the helix. Some of the operations in Rhino are approximations. Sometimes if your tolerance is not set right, it can send things flying around. Anyways, I'm going to change the layer of that. We might use this. Let's see what I can do here. So if I join those, I can use those for a landing later. I can just rotate the whole works, right? So I might do the same. These, just get that out of my selection set, hit enter. Okay, we got that. Let's array curve the inner. Delete the top one. Make sure we're at R0. Join those. Got to double check that, sorry. Normally it's a time when I take a break or shut Rhino down for the day, but I want to finish this video because I might not have enough time in the near future to get that done. I'll join those, and then I'll join go here. Wanted to rotate both of them, but whatever. And yeah, let's make the landing a reasonable length. Let's say 12. I'll go with that. So depending on what you're doing, like if you're doing handrails or something, it would be prudent to also maybe split these helixes, because you'll use these helixes for, that's why you want to save them. You're going to use them not only for laying out your stair treads, but potentially also for sweeping, I guess, your handrails, maybe arraying the handrail post along the curve, stuff like that, right? You want to keep these. But yeah, in this case, I just kind of want to get this stuff done, get it finished, and plan my, I guess, my next video, or actually finish the work I'm supposed to be doing right now. This is kind of funner, so it's not unenjoyable. Okay, so this we're gonna trim. So hopefully this works, or it's going to make a fool out of me. But if it does that, I'll probably just won't share this video. So anyways, let's loft these together. I think I want to do straight sections. And that is not the result I was hoping for, unfortunately. Let's see. Another thing we could do is a sweep 2. Let's go here. Thought for sure the loft would work. That's crazy. Whatever. Whatever. That's why you gotta know more than one way to do things. So I got this curve. Sweep 2. Is that gonna get the whole rail? It is. Sweep shapes. Oops. Find it challenging sometimes because a lot of the Rhino commands, you really got to pay attention to the command line. Their behavior isn't necessarily consistent because some commands you have to enter to confirm even if you only have one option. Looks funny, but I think that's just my camera. But we'll find out soon enough, right? Okay, so I'm going to interject here because at this point I just started modeling the support. I had a little bit of trouble getting the support to close into a closed solid poly surface. I eventually figured it out, but it was darn near, I think maybe even over 30 minutes just to build the support itself. So I still have the video, so I could upload it to YouTube if anyone actually wants. Some of my issues might have been due to units, but I'm not quite sure about that. Or sorry, not units, but the tolerance, rather. So whatever it was, I threw a bunch of different things at it and got it sorted out. Let's go into shaded mode so you can see like the quality of the surfaces. They're not bad. For what I do, this is totally serviceable. I had some trouble joining the landing to this, but that was easy enough to solve. Instead of a Boolean union, I had to split it and then join these together. But yeah, so it wasn't too bad, but wasn't too good, and made me stray too far away from the actual stair modeling. So that's been excluded from this video, but I can upload that. I recorded the video anyways, if anyone requests that. Yeah, so anyways, with all that out of the way, that pretty much wraps up this video. Just want to say that you saw me model stairs like a few different ways. That's by far and away not the only way to model stairs. There's a lot of different approaches you can use. So yeah, if you have a better way, a faster way, definitely let me know in the comments if you feel the need. Feel free to link your own video in the comments as well. I'll take no offense or exception to that. As far as future videos go, I would be kind of keen on maybe doing like a full video of how to actually put the handrails onto stairs, like these winders. So I'm kind of interested in doing that. These stairs, probably with a smaller inner radius, I wouldn't mind doing up a set of steel spiral stairs and some mock shop drawings. That's kind of something that interests me because I've been experimenting with kind of, well, technically doing drawings that could be used for steel shop drawings in Rhino. I don't recommend doing that, but just if it's like a one-off or something, helping out a contractor or whatever, you can actually do that in Rhino and save yourself the trouble of obtaining a license or having to learn another program that's perhaps is better at it, but just not having the knowledge, of course. So yeah, that's one thing I wouldn't mind doing, is making these spiral stairs and figuring out the supports and how it would all look and tie in together and stuff like that, and maybe do some cool renderings, or at least whatever I can manage on my computer.